Welcome to BKW Physics. I'm Mr. McConley. We're going to talk about phase shifting and phase in general today. Phase of waves. So if you have a wave, we learned earlier that if you picked a particular point on a wave, say point A right here, and then you moved forward one wavelength, say that was here, then the difference between those 2 points that I've just marked is 1 lambda, and it can be said that they are in phase. They're in phase. And I could pick points like, B and B prime also and say that those are in phase. They're always one wavelength apart. But phase shift is the next step. And phase shift goes something like this. If I have a wave, and now I shift that wave, in other words, I slide it over, and for this example, let's say that we're going to move it over 360 degrees. So we're going to work in degrees here for a minute, and I'm going to also write it in another form. If I move this over 360 degrees, it means basically move it one whole wavelength over. So now the phase shifted wave has basically looks like it's been tacked on the end because I've taken it from this position and I've shifted it to that position. That's a 360 degrees phase shift. The other way you can refer to that is as 1 lambda or 1 wavelength phase shift. You've moved it one whole wavelength in a certain direction. Now, those aren't very useful or common. More commonly, you would be starting with a wave, and you would say something like 180 degree phase shift, which if you kind of are following the pattern means take the wave and move it over 180 degrees, which would translate to now having the wave look like that. Now that's half a wavelength shift. And by the way, this one's a key concept because this one has the maximum destructive interference. Because now that there's a crest and a trough that are lining up, they will completely annihilate, cancel, and destroy each other. So that's maximum destructive interference when you shift it one half of a wavelength. So, what if you said 0 degrees? If you said, I'm going to phase shift at 0 degrees, where is your wave? Yeah, and most of you can see, well, it's going to be right up top. It means you're not moving it at all. And if that's the case, we'll say we moved it 0 lambda. We didn't move it. If that's the case, what's going to happen if these two waves are 0 degrees compared to one another is this is going to be the case for maximum constructive interference. So maximum constructive interference because they basically both add up, so you can see that you're going to get double the size trough and double the size crest because of the alignment in this case. Now there's other ones, like you could shift it 90 degrees, 45 degrees, and whatnot, but these are the keys that the Regents will focus in on. They want you to understand the main